Hey guys, this is Andre here, and before I continue my competitive programming guide, I realized that I actually had a very big problem. I have a Manila folder with a bunch of competitive programming packages, and if you know me, I'm pretty lazy. There's no way I'm gonna type them out in order to share them with you guys. So I figured I would use a little bit of computer vision to turn those photos into text that I can just upload into my GitHub so that you guys can have it, and in order for me to be able to read the input and output of the different problems. So let's get to it. Today you're gonna be learning a little bit about computer vision and text recognition. So we are going to be using NumPy, OpenCV, so it's OpenCV Python, and we're gonna be using this amazing library, the Python Tesseract, which on Linux is really just 3 install commands. And then if you are on Windows like me, you're gonna have to install an executable and then run the pip install command. So let me get the link to their GitHub. Oh my god. So this file, I'm just gonna write some comments as a class to quickly process a photo with text and transform it into a text file in order for us to read input/output. Okay, so like I said, we're gonna need TV2, we're gonna need, you'll see why we need system, and then good old NumPy. So we are going to we're going to be processing an image, so I'm gonna have the user input the image. So user will input the image path. So we're gonna be we're gonna be looking at the command line arguments, and they need to provide at least 2 arguments. If they don't, we're gonna have a little text saying like, please enter an image path. And then we return. Very nice and easy. Let's test it out. Python image. I have a couple images, so let's try this one. It works perfectly, and then if we don't input that, then we're gonna ask for the use case and then return. So the first function we're gonna need is to be able to read the image from the path. So we're gonna say the image path is equal to the second element in our arguments list, and then we're gonna pass it into our function here. So this is not gonna be anything complicated. We're just going to say image is cv2 dot image read function that just takes a path, and then we can maybe print like reading the image and then the image path, and we return the image, and then we can see what it looks like as we read it in. Oh yeah, and there we go. And of course, we want to test it with the image path, right? Okay. Half of the time programming is just like syntax. And you can see these are our pixels. It's an array of pixels, right, of the image. Like three values for red, green, and blue RGB. Perfect. So we don't want to be printing the image anymore. Okay, so we read the image into pixels, right? So now let's get to the good stuff. We need to actually, in order to use the Pi Tesseract, we need to specify the path to the executable from the installer that we installed into our system. So I'm getting it from my file system. So it's gonna be Tesseract, I think it's command. I'm gonna have this string, and that's where I installed it on my computer. And yeah, so the way that this will basically function is read the image into an array of pixels, and then we need to pre-process the image, and then transform the image into text. Okay, so that is the main idea of the code we want to accomplish. We want to read the image, pre-process it, and then we're going to transform it into text. So usually in computer vision, when you pre-process the image, you have a few techniques that we usually perform. Usually you turn the image into grayscale, and then from grayscaling you turn it into binary by applying a threshold to the value of the pixels in order to either make them black or white. You can apply like canny edge detection in order to make the contrast of edges, like make the edges like contrast with the background so that it's easier to detect. You can apply erosion to the pixels and dilation. Usually you apply them in a combined manner for the best effect. And I mean, I'm not gonna go super in depth. I can, if you guys want me to go more in depth about these topics, leave a comment below and I can make a more in-depth video about the different image processing techniques using computer vision. I'm not a super expert, but I have used them before, right? I took a computer vision class at UT. I've done some projects. Yeah, it's just a lot of math, and I'm trying to keep this video a little small, but yeah. Okay, so the next step was, now that I read the image into a three-dimensional array containing a dimension for each color, so red, green, and blue, you kind of, in order to make the math easy, the general idea is to average all three values into the gray component value, and then you have your gray image. The next step is to now apply a threshold and turn this gray image into black and white, so the binary image, where 0 is black and 255 is the color for white. What I tried to do next was to apply a adaptive Gaussian thresholding, which instead of just having one global value to make our binary image, would actually use the values of neighboring pixels. But as you can see in my binary image, it was creating a lot of noise. And then a solution to do this is to, if you have objects in the foreground and you want to remove them, you can open your image by applying erosion and then dilation. But if you have like little holes that you want to close out, like in the background, you can close your image, which is the opposite. I was then trying to maybe use canny edge detection to capture the more important things on the image. But as you can see, my thresholding was really not good in order to create my binary image, which was just causing a down spiral effect. So then I decided, and I knew rather, that I had to fix my binary thresholding. So after having applied the morphology that I explained, and trying to actually find the contours in the image and draw them in to to completely fill in holes, and applying some blurring to my gray image before turning it into a binary image, I was actually, as you can see, getting pretty close to capturing the text in order to apply the optical character recognition, but it was still not completely working. And that's when I realized one very important thing. I actually realized that the sample text that I wanted to capture, it was always black text on a white background with a very high contrast, as opposed to my surf image, which actually had white text on the color background with lots of places where there was the same white hue in the image. And even though I was very close to getting a solution working for this, it was not going to be applicable to what I wanted. So I actually decided to, in order to make this better for me, to make the text black on the serve image, my test image, in order to correctly test and produce my capturing and image processing code to be able to capture the text image that I was actually going after. Okay, so now I had to change my code to account for the fact that the text was going to be black, not white. So my binary inversion basically had to flip on itself so that I would keep the black text, which I was filtering out before. As you can see, it wasn't terribly difficult. And then I just fine-tuned my model a little bit, messed around with the size of my kernel in the morphing, messed around with some of the blurring and the contours in order to fill out any noise, remove noise from the image and fill out small circles. And as you can see, it was starting to actually get the output that I wanted. So you can see the text serve on the screen was being printed as the contents, right? I'm about to print it here. Boom, you can see it on the PowerShell. Then I decided to do some cleanup, but I still felt like this could be made a little bit better. I wanted to explore the idea of applying a mask to my image in order to really highlight the text. And also, after reading more of the documentation on the Pi Tesseract, it really showed that in order to correctly do the optical character recognition, the OCR, you should have a black background with white input of what you're trying to capture. So my current code was producing that, and I was trying to highlight it with the mask, but it was not effective. I was then running into the issue of trying to process my already black and white image, which only contained text, this image here for the problem, and I was actually seeing that the image processing I was applying to the serve image, which had other colors in the background, right, was being very effective for getting rid of those colors. But in this case, because this had a purely white background, it was just removing all the important information. So I did decide to tweak my code a little bit in order to allow a mode to be passed in to do things a little differently if my image is already in black and white. Even though it was in the RGB space, my input image, it was read as a NumPy array of where the coordinates of the array, right, are really each pixel, and there's like 3 dimensions for the RGB colors. It really is living in the binary space of colors from ranging from 0 to 255. So now I will explain these changes in more detail and show kind of the final version of the code, and just go overall over everything and try to explain it as best as I can. I could pass in a binary or like an RGB mode. So I realized that sometimes my pictures, like in my actual use case, let me pull it up here. They might have the text that's already black, and they might have a background, and that's the text that I'm trying to determine, or rather to capture. But sometimes I might just take pictures of like black text on a white background. I mean, this is already a black and white image, right? But it's still in the RGB color space. So we have to do things a little bit differently. The thing with like image classification and computer vision is you kind of have to make it specific to the image, right? So there's some tweaks here and there, but in general, because of like thresholding, I did not want to apply contouring or morphing to my image, that if it was already in black and white, because it would actually, instead of removing noise, it was removing some data that was actually needed. So let me show you basically how the code works at the end. What I ended up doing is I pass in the mode, the image path, I read the image. This is just how I initialize the library. This is the executable on my system to the exe, and then basically it goes through the sequence to turn our image into a gray image. So basically all the colors, right, are mapped into grayscale, and then we apply a threshold to turn our image into a what's really known as a binary image, which is black and white, with the value for each pixel, the value of 0 being black, the value of 255 being white. And you can use this to get rid of all the non-important details in the image. In this case, as I have shown this image countless of times, this is my gray image. Of course, the black text is gonna stay super dark gray or black, and you can see how the colors are transformed. And then I really did not want the background, so I set a very low threshold, or to have, it really is the inverse of the threshold, but yeah, to basically make the black text white and everything else make it black. But as you can see, there are some spots here where some dark spots on the waves, right, which are still being preserved. So that is where we apply the contours. We find contours in the image and we try to get rid of them. So I can show you the binary image and the contour image, and I fill them in with black, so very small areas, and then there was still a little bit left, and that is where we can use opening. Opening is a very useful technique used in image processing, where you apply erosion, kind of like, think of like the soil getting eroded a little bit to the pixels, and then dilation, which is just really, you create a kernel and then try to increase the size of like small things on the background, and it's very just without getting too much into the math, it's very useful for like noise removal. As you can see, got rid of this white stuff, right? And then I just use the library to capture the text from this image, and the output text was surf. Now if we look at my other image, you can see clearly that this was already black and white, so applying the grayscale made it be a little weaker in strength. And yeah, here I turn my image into a binary collection. You can kind of see the text, and in this case, because the ratio of the pixels, right, that the text encompasses, as compared with the other image where the text is very big, if I actually apply contouring to this, it would try to fill out, because the text is very small in relation to the entire picture, it would try to fill out the white text as like it would try to fill them out, thinking that they're holes, and it would just erode the text away. Same with opening my image. So that's what I'm saying. These techniques are very specific to your image, right? So if you go from a very large image or an image with very large text to an image with small text, you kind of have to cater your code and parameters a little bit, unless you're really digging down and like looking at ratio portions of your image at a time. But it was more complicated. I wanted to keep it simple. But yeah, as you can see, we get the output of the text, and it's right, it's a bad student. It's the same output from the image. And yeah, I hope you guys enjoyed this video, and stay tuned for more. I will be doing, some of you guys requested a video on how to make a makefile. So I will be showing you guys that on the Linux subsystem that it's integrated with Windows, and maybe doing some C, like a very sample hello world C program, and then how to make a very nice and simple makefile, do like a make clean, different things, right? Useful things. So stay tuned, and I am making a video showing you guys my 20-minute daily full body stretching routine, and it's great if you're an athlete or a normal person. So yeah, stay tuned for more, and let me know in the comments if you try any of this out, if you find some images where maybe it doesn't work so much for you, and then how you tune this code to make it work. The idea is that this is not going to work for every single image in the world, but this is a very strong basis for you to be able to cater this code to make it applicable to what you want. Alright, so that's all for today, and stay tuned for more.